Hey, we're doing page 19 and 20. Uh, from this sheet, we're going to start working with something called a sample space diagram. Right here we have an example of a sample space diagram. Um, it is showing the events when you roll a red dice and a blue dice, each having 6 sides, and the relationship between the two. So, for example, this is a convenient way to mark like a certain event. Like, for example, oh, the red dice rolls an odd number and the blue dice rolls an even number. And then you can mark all the points where that event is true, and then you can count up all the points and figure out the probability. Okay? So, in the first problem here, we're going to use dice, but we're going to use a tetrahedral dice. Um, these dice, have you ever seen these before? They're used by nerds when we play Dungeons and Dragons. I don't think people do that anymore, but when I was in high school or junior high and I was a nerd, I used to use these dice. Okay, so let's look at when you roll a tetrahedral dice, which rolls numbers between 1 through 4. So we have a blue dice and we have a red dice, and I made a diagram here, and I'm going to color in the intersections whenever it gets the event that I'm looking for. I'm going to color in the event that the red dice is greater than the blue dice with the red highlighted. Okay, so for example, if I roll a 1 with both the red dice and the blue dice, then the red dice is not greater. What if I roll a 2 on the blue dice, but a 1 on the 2 on the red dice, but a 1 on the blue dice? Yeah, that's greater. What if I roll a 3 on the red dice and a 1 on the blue dice? Yeah, that's the red one is greater. What about a 4 on the blue dice, or the red dice, and a 1 on the blue dice? Yeah, that's in the event also. Now we can go to the next row. What about when I roll a 2 on the red dice and a 2 on the blue dice? No, that doesn't count. What about when I roll a 3 on the red dice, but blue on the 2 on the blue dice? Yeah, that counts. What about 4 on the red dice and 2 on the blue dice? Yeah. Okay, so there's a pattern here. You can see that like the next row is going to be that. And then the final, the top row where the blue dice rolls 4, no. No rolls on the red dice can be greater than that. So what are we left with? We are left with, we're going to count how many events satisfy how many events satisfy the condition. There are a total of 6, right? So there's 6 combinations which satisfy the condition, and then the other intersections here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 do not satisfy the condition. So that would be the total number of intersections of this graph is 16. So it's 6 out of 16 is the probability. Find the probability that the difference between the numbers on the dice is 1. Let's see. So we'll put that in purple. Oops. Purple highlighter. The difference between the numbers on the dice is 1. The difference. So that would be 2 and 1, 2 and 1, 3 and 2, 2 and 3, 4 and 3, 3 and 4, and that's it. So there's 6 purple events, and that's also over 16 possible outcomes. Now we'll go to C. So this is the red dice shows an odd and the blue dice shows an even. So that would be red dice shows an odd. So that would be like 1, and then blue dice shows an even. So that would be, it would be 1, 3 on the red dice, and it would be 2, 4 on the blue dice, and the intersection of those. So it would be this one, and then this one. Okay, so it's 4. Okay, so it would be 4 events out of 16. Find the probability that the sum of the numbers on the dice is prime. So that would be, let's see, it would be like summing when the sum is like 1, 2, 3, 5, and 7. So, for example, 4 and 3 would be one combination. That's not a very distinctive color. We'll use pink. Okay, so 4 and 3 is 1. 3 and 4 is 1. Those add up to 7. What about things that add up to 5? 2 and 3? 2 and 3? 3 and 2? What about things that add up to 3? 1 and 2? 1 and 2? What about things that add up to 2? 1 and 1. And is that pretty much it, I think? Yeah, so that's 1, 2, 3, 4, 5, 6, 7. 7 outcomes. 7 outcomes. And 16 total different outcomes. Okay? Alright, now we'll go to number 2. Tetrahedral dice again. Oh, 1 tetrahedral dice and 1 6-sided dice. So first thing is I drew the diagram, sample space diagram. And then I'm going to find all the events where the number on the tetrahedral dice is greater than the number on the ordinary dice. So that would be, for example, 2 on the tetrahedral dice and 1 on the blue dice. 3 to 1, 4 to 1. What else? 3 to 2, 4 to 2, 4 to 3. So I think that's pretty much it. Any of the others, the blue dice total is going to be bigger than the red dice number, right? So what do we have here? The total number of intersections here is 4 times 6, which is 24. And the number of outcomes that satisfy the condition are 6. So this would be 6 out of 24. The difference between the numbers on the dice is more than 1. We'll do that in purple. So that would be 2 more than 1. So 2 minus 1 doesn't cut it. 3 minus 1, okay. 4 minus 1, okay. 5 minus 1, okay. 6 minus 1, okay. 3 minus 2 doesn't cut it. So these. 4 minus 3 doesn't cut it. So it'd be everything greater than that. What about 6 and 4? Yeah. Let's see. 2 minus 1 doesn't cut it. 3 minus 1, yes. 4 minus 1, yes. 4 minus 2, yes. 4 minus 3, no. Okay, so all the purple ones, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 outcomes that satisfy the condition out of 24 total. Now, see, the ordinary dice show an odd number, and the tetrahedral dice shows an even number. So that would be the 6-sided dice shows an odd number. So it would be this. Oops. It would be this one, and this one. And this one would be even numbers, right? Okay. So where are the intersections here? It would be here. It would be here, it would be here, and here, it would be here, and here. So that would basically be 6 possibilities. Okay, 6 out of 24. Sum of the numbers on the dice is prime. So that would be like, which one of these numbers would add up to 11? So that would be none. Doesn't add to 11. 10 is not a prime number. 9 is not a prime number. 8 is not a prime number. So 7. Which of these combinations add up to 7? Well, 6 and 1 does. 5 and 2 does. 5 and 2. What else? 4 and 3 does. 3 and 4 does. Okay, now we go down to 5. 3 and 2 does. 2 and 3 does. 1 and 4 does. 4 and 1 does. That was 5. What about 3? 2 and 1 does. 1 and 2 does. And then there's 2. 1 and 1 does. Okay, so let's count those. So there's quite a few. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think there's 11. 11 out of 24. How about the 2 dice show the same number? Okay, that's only going to happen here, 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 and here. So that's 4 possibilities, right? 4 out of 24. Okay? All right. Number 3. A box contains 3 cards numbered 1, 2, 3. A second box contains 4 cards numbered 2, 3, 4, 5. A card is chosen at random for each box. Draw the sample space diagram for this experiment. Okay, so we've drawn the sample space diagram. Let's show the events that the cards have the same number. That's a pretty easy one. It's just, oops, that's not it. Not that easy, I guess. 2 and 2, 3 and 3. So there's basically 2 possibilities out of a total of 4 times 3, 12 outcomes. So 2 out of 12. Okay, the largest number drawn is 3. So that would be the largest number drawn is 3. So that would be 3 and 2, 3 and 3, 2 and 3. Anything that, oops, that would be anything with a 3 drawn, and then a smaller number drawn. Okay, so this would be 3, yeah, 3 and 2, yeah. So that would be 4. 4 possibilities. 4 out of 12. Sum of the 2 numbers on the cards is less than 7. The sum of the 2 numbers on the cards is less than 7. So 5 and 1, and 5 and nothing else. 4 and 2, 4 and 1. 3 and 1, 3 and 2. 3 and 3. 2 and 1, 2 and 2. 2 and 3. And I think that's it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So there's 9 possibilities that add up to 6 or less. The product of the numbers on the cards is at least 8. Let's see. So that would be at least 8. So that would be 5 times 2, 5 times 3, 4 times 3, 4 times 2, that's at least 8, right? And 4 times 1, no. 3 times 2, no. 3 times 3, 9. So it looks like there are 5 out of 12. At least one even number is chosen. So that would be one even number is chosen. So that would be at least one even number. So that would be 2, 4, 2. So it would be anything here to here, 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 here. So it would be 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities over 12. Okay. 2 more. 6 cards numbered 0, 1, 2, 3, 4, 5 are placed in a bag. 1 card is drawn at random. Its number noted. Then the card is replaced. Second card is then chosen. Draw a sample space diagram for this experiment. So here's the sample space diagram. Find the probability that the cards have the same number. So that would be 0, 1, 2, 3, 4, 5. So that would be 1, 2, 3, 4, 5, 6. There are 36 possible outcomes, so 6 out of 36. And then the next one says the largest number drawn is prime. So that would be, let's see, 5, and the largest number drawn is 5. So that could be any of these. If the 5 is drawn, then that's definitely the largest. If the 3 is drawn, then it would be any time the 3 is drawn together with a smaller number than 3. And then if the 2 is drawn, along with this other one would be 2 or less. And then if the 1 is drawn, okay, so that's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 26 possibilities out of 36. The sum of the two numbers on the cards is less than 7. So that would be less than 7 would be the sum. So that would be 7 and 0, or 5 and 0, 5 and 1. 5 and 2 is 7, so not that. 4 and 0, 4 and 1, 4 and 2. 3 and 0, 3 and 1, 3 and 2, 3 and 3, but not 3 and 4. 2, you can see the pattern developing now. Okay, so that's pretty much everyone except for 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So everything except for 10, so that would be about 26 over 36. D, the product of the numbers on the cards is at least 8. So that would be product of the numbers on the cards. So that would be 2 times 4 and 4 times 2. And what about 3 times 3? 4 times 4, of course. 5 times 5, of course. 1 times 5, no. 2 times 5, yes. Okay, so the rest of them will color in. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. That would be 11 out of 36. At least one even number is chosen. At least one even number is chosen. So that would be, and I don't know if they would consider 0 an even number. If they do, then it would be all these. So it would be, you know, this row, this row, this row, this row, this row, and this row. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 27. This last one is kind of interesting because it's the same experiment as number 4, where you draw the card out, but after you draw it out the first time, if you pick a 0, for example, you don't replace the card. So on the second draw, if you picked a 0 on the first draw, you're not going to pick a 0 on the second draw. If you picked a 1 on the first draw, you're not going to pick a 1 on the second draw. So the way the sample space looks is like this. Do you see how the circles are drawn in every intersection except for 0, 0, 1, 1, 2, 2. Those are all clear. So instead of having 36 possible outcomes, we have less. We have 30 possible outcomes. So we're going to have, the numerator is going to be similar to before, a little bit different, but similar, and then the denominator is always going to be 30 instead of 36. Okay? So they're going to lead us through all the same ones again. Find the probability that the cards bear the same number. Well, they're never going to bear the same number because you're not replacing the card after the first draw. So you're never going to get the same number twice. So this would be 0. The larger number drawn is prime. Okay, so these are going to be similar to, the numerator is going to be similar to the other one. So let's see. The larger number drawn is prime. So like 5. Okay, if 5 is drawn for either one. 4 is not prime, so we're going to ignore 4. If 3 is drawn, it would be fine, as long as the 3 is the bigger number. 3, 4, you can't have that. 4, 3, you can't have that. If 2 is drawn, that would be fine. And if 1 is drawn, that would be fine, as long as they consider 1 a prime number too. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That would be 21 out of 30. Next one, sum of the two numbers on the card is less than 7. Less than 7. So that would be like anything less than 3 plus 4. So not 3 plus 4, but 3 plus 0 is okay. 3 plus 1 is okay. 3 plus 2 is okay. 3 plus 4 is not. What about 5 plus 0? Is that less than 7? Yeah. What about 5 plus 1? Is that less than 7? Yeah. Okay, so we can circle the opposites of those two. And then, of course, 2 plus 1 is fine, too. These are all fine. Okay? So that would be, what about 4 plus 0? That's fine, too. 4 plus 1, that's fine, too. Anything less than 7 is fine, so 4 plus 2 is also fine. 4 plus 2. 4 plus 3 is not. Okay. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 2, 22. 22 out of 30. Number D, the product of the numbers on the card is at least 8. The product of the number on the card is at least 8. So 5 times 4, of course, would be fine. That's like 20. 5 times 3, that's 15. That's way over 8. 5 times 2, that's still over 8. 5 times 1, no. 4 times 3, that's still over 8. 4 times 2, that's at least 8, yeah. 3 times 5 is okay. 2 times 5 is okay. 1 times 5 is not. 4 times 2 is okay. 4 times 3 is okay. So that gives us 10. So 10 out of 30. What is the chance that at least one even number is chosen? So that would be at least, but that's not going to happen. So it would be 2 and 0, 4 and 0, 2 and 1. Actually, all these are fine. Anything with 0 is fine. Anything with 2 is fine. Anything with 4 is fine. Anything with 2 is fine. Anything with 4 is fine. Okay, so what do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24. So 24 out of 30. Okay, and that's it.